Hello guys, welcome again to our homework solutions. So the last homework is homework 13, in which we review the pipelining of instructions in microprocessors in general. So the first question is very straightforward, is regarding the example of the laundry that we studied in the lecture, in our first two slides in the slide deck in the lecture of pipelining. So what you need to do here, or what you need to know, is basically the formula which calculates the speed up. So the speed up was basically 2n over or divided by half n plus 1, or n minus 1, sorry, plus 2. Okay, so that's basically the formula that you can apply to calculate the speed up for any number of loads. So n here is the number of loads, how many wash loads you're gonna load to the laundry basically. So the first question here, we need to know the speed up at 8 loads. So what you need to do here is to remove n and put 8. So n equal to 8 here, n equal to 8. That's it. And the answer will be 2.91. The second question is we need to know the number, the speed up when we have infinite load. Basically, no, there is no, of course, there is no infinite loads, but basically, very high number of loads, with n much larger than 1. Okay, or a limit, n tends to infinity basically, and that will be basically the number of stages that you have in the pipeline. So in that example, we have 4 stages. We have the washing, we have the drying, folding, and the closet. So basically it's 4 stages. So when n equal to infinity, this formula will give you basically 4 for 4 stages, or the number of stages in general. Good. The third question is about also another example in the lecture. So we are asking, for this particular example, what would be the speed up? So as you see here, each instruction takes 5 cycles. So if there is no, pipelining, we're gonna take 25 cycles. As we see here, we have pipelining. We pipeline the instructions. So basically, instead of taking 25 cycles, we take only 9 cycles. So with pipelining here, we take only 9 cycles. So basically, the speed up is basically 25 over 9. Very straightforward. In that example, however, we have some data dependency between, for example, these instructions and the first 2 instructions. So basically, we're gonna have some bubbles, as we studied in the lecture. So these bubbles, of course, will affect the speed up. So now we have again five instructions, but because of the data dependency, we're gonna execute them in 18 cycles. Still, with no speed up, with no pipeline, we have 25 cycles. But now with pipeline, we have 18 only. So the speed up is basically 25 over 18, which is 1.38. Here I'm asking, what if the instructions are independent? So for some, something happened, and this instruction were independent, and there are some techniques that can convert dependent instruction into independent instructions. But this course is not the place to, or it's out of context of our course. It's an advanced course. So if we have such technique and we could convert these instructions into independent instructions, in that case, of course, we're gonna, instruction 3 will be executed or finished at cycle 7. Instruction 4 will be executed and finished at cycle 8. Instruction 5 move LBL will be executed and finished at cycle 9. Because if they are independent instructions, then we can start the, you know, and finish in 5 consecutive cycles, you know, for each, you know, for each instruction with no bubbles. So in that case, you know, the speed up is 25, which is the number of cycles taken to execute the instruction with no pipelining over 9. Okay, and that will give us 2.78 speed up. For this question, I'm asking about, you know, what kind of causes for the bubbles. Okay, we studied two, you know, two hazards, two kind of hazards that can cause bubbles. One of them is data dependency, and the other one is, you know, the jump instructions. So here we have basically the two causes. So we have, you know, these bubbles here is because of data dependency. Why? Because here I'm saying jump F0. So I need to check the, you know, the flag register, the 0 flag register, or bit in the flag register, which will be affected by that, you know, that instruction. And, you know, in the right back here at the fifth cycle, you know, the flag register will be updated. So I cannot execute until, you know, the fifth cycle happens. So these bubbles here are because of data dependency. How about the other bubbles? So the other bubbles is basically, you know, because of the jump here, you know, we don't know after executing the jump whether we go here or we go here. If the branch is taken, we're gonna go to that guy. If the branch is not taken, we're gonna go to that guy. Looks like here the branch is taken, and we moved it to high here. So the other kind of you know, of bubbles here is basically which are these bubbles here, you know. These are, you know, branch, you know, bubbles. Okay, so the correct answer is that you should choose both branching hazard. Of course, there is no such thing called label hazards. Okay, and of course we have bubbles, so this is also incorrect. Okay, guys, that was basically, you know, homework 13. Thank you very much for watching, and good luck in the exam. Bye bye.